गुड इवनिंग एवरीवन, हाउ आर यू? जल्दी से चैट में बताओ कैसे हैं आप सब. गुड इवनिंग गाइस, गुड इवनिंग, गुड इवनिंग. ओके, सो आपने कल का प्रोग्राम किया? डिड यू ट्राई द प्रोग्राम्स? नॉट गोट द लिंक. आकाश, विच लिंक आकाश? गुड इवनिंग, गुड इवनिंग. Yeah, tell me Akash, which link you didn't get? So tell me in the chat that how many of you tried the programs. I'm also good, Indrajit. Yeah, tried. Shivam tried the programs. Akash also tried. Okay, yes. Ravinder also tried. Assignment link. You will get that. Join Telegram group firstly. In Telegram group, you will get the assignment link as well. And the Telegram group, you can join Telegram group where you will get the assignment link. And for the Telegram group link, you can check in the description. In the description, link is provided. So using that link, join the Telegram group, and in that you will get the assignment. Okay, it's that simple only. Yeah, everyone tried. That's cool. And same with the attendance link. You will get the attendance link in the description. So over there you will get that. Okay, completed. So did you find the those programs easy, or did you face any difficulty? Tell me. You will get in the live chat the Telegram link. Okay. Let's Upgrade team will provide you the link in the chat as well. So over there you will get that. Okay. Yeah. Okay. So you enjoyed the programs. Perfect. So let me share my screen. Just a minute. Yeah. So very easy. Oh, easy, easy. Everybody is saying easy. Perfect. 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 Okay. So today we will start with a new topic that is recursion. Okay. So revise yesterday's topic. Okay. Yeah, perfect. We will do that. Okay. No issues in this. I'll tell you. We'll start with in yesterday's lecture we discussed about the basic. What is data structure and algorithm? We learned about the basic definition of data structure and algorithm. Then we discussed about why data structures and algorithms is important for us. Why this subject is considered as the core subject. To grab any technology, this is the foundation. Data structures and algorithm is very crucial for you to learn this subject. Okay. And then after that, when we discussed about the algorithm parts, that algorithm is something, it is a step by step procedure to accomplish any task. Okay, it means you have to build your logics whenever you get some problems of real world scenarios and you have to solve that problem. For that you want some procedure to follow. It means you have to write some algorithm. For that it means you have to build your logic strong. So we started with pattern printing. We did many programs for that using the concept of loops, and at the end of the session I provided you some assignments on the basis of same concept, some pattern concepts using loops concept, right? Okay, when will we get the certificate? You will get the certificate at the end when you register yourself, when you mark your attendance and you do the assignments. Today at the end of the session you again get the assignment, so when you complete all these stuffs you will get the certificate. Okay, you will get the certificate. Firstly learn the concepts. Okay, I told you the procedure to get the certificate. Okay, so let's start. Okay, now we'll start with the recursion. Okay, tell me how many of you are clear with this concept? How many of you know the definition of recursion? Okay. Someone is saying that I taught DSA in C++, so you face difficulty to implement that algorithm in different language. I don't think so. DSA is all about the logics, okay? It doesn't depend upon the language. You can use any language. If I'm saying you that I use for loops, okay? So there is nothing new in this. You will directly use nested loops to implement your programs, right? The only difference is that when you define the main function, when you are defining your main function, the syntax for main is different in Java. That is only different part. Okay. So for today's session as well, we will focus on improving our logic, not on the language. Okay. So let's start. Someone, okay, yeah, I used okay Python. Yeah, someone is saying that when a function calls itself, this is recursion. Okay, yeah, how we define recursion simply is when a function calls itself. Okay, everyone can read this definition anywhere, or anyone can study this definition. But what does this mean? That when a function calls itself, let me firstly explain you what does this function call mean. Okay, we always write programs. When we how to write a program, we always start with the main function, right? In the main function, what we do in general, we define our statements. Let's say if I say cout hello, hello will get printed on this console. This is the simple, right? So let's say I define a function here. In my program I have defined a function, let's say like this. I'm using a function fun. Okay, and in this function I'm writing a statement. Let's say I'm writing hello everyone. Okay, when I'm writing this statement, how this function gets called or how this function gets executed? When in my main function I call this function. So how a function is called? We in general call that function in main. So I'll write here fun. This is my function calling, right? When I call a function, what will happen? This function gets executed. Okay, now see, if I show you the function calling internally, what will happen? Basically my execution starts from the main only. So what will happen? Main will say that okay, start execute, print the statements. When a statement comes which says that there is a function calling, it means I have to call this function and execute this function firstly. It means I pause the execution of main. When I pause the execution of main, the main function would be stored somewhere. So it will be stored in memory, and this memory is known as stack memory. Okay, so main function will reside in our stack memory so that our function fun gets executed completely. Okay, now what will happen? My main function is paused and this fun function gets executed. What this function will do? This will come to this part, right? So when I execute this program in my console, I will get hello everyone, right? And this function returns that I have completed my task is over. Now what will happen? My main again starts executing. This is simple function calling. That when I call a particular function, this function gets completed first and then my main again starts its execution, right? Let's take one more example of function calling only. Let me define my main and I'm writing here. There are few statements. After that, I'm calling fun. Okay. Now, when I'm defining my this function fun, what I'm doing, I'm writing here cout in fun. Okay. Now, when I let me write here this. Okay. What I'm doing here, my fun function is calling another function. What's that? Fun2. So there must be a definition for fun2 in the program. So let me define that as well. Let me write here as cout hello. Okay, now please observe carefully what I'm doing. I'm saying that when my program starts executing, my memory gets allocated for that. Let's say I started execution from the main. When I entered, I checked a few statements. After that, I found that there is a function calling. It means my main function stops it working. It means it pauses and it will reside in the main memory, right? After that, what will happen? This function gets executed. So when I come to execute this function, again, what will happen? This infun gets printed, and after that, what I find that there is some other function calling. It means again I have to pose this function fun and firstly have to execute fun too. It means again I have to keep this one into my memory. So what I'll do, I'll put this fun on the top of main so that my fun2 gets executed, right? When my fun2 gets executed, what will happen? I'll move to this part, and when I execute fun2, it gives hello, right? So when it returns, what will happen? My function fun is again resume. It will start its working again. Now when I am at this point, there is no further statement, so my fun is executed completely. So after that, I again come to this main function here, and if there are any statements at the end, they will get executed, otherwise my main is completed. So with this concept, what you understand, that whenever I call function calling, it uses memory. What kind of memory? Stack memory, so that it follows the principle of LIFO, last in first out. What does this mean? We started the execution from the main, but firstly fun gets executed, but when there is another function calling, fun2 gets executed, then fun executed, and lastly main executed, right? So last in is executed firstly. Did you understand this basic concept of function calling? Tell me. Okay. Yeah, tell me, how many of you understand simple this concept of function calling? If you are clear with this function calling, then we will start with the recursion. That how recursion is being used for function calling. It means it calls the function itself only. Here we are using different functions. Now I'll tell you that how to call a function itself. That is the concept of recursion only. So yeah, tell me. Yes, someone is saying yes. You get the understand this concept. Understand. Yeah, perfect. Okay, cool. Now, what I said in the starting is that recursion is all about calling a function itself. A function calls itself. What does this mean? When I was defining a function fun, let me write this. And if I say that after some statements, I call this function again. Now what is happening? I am calling this function again and again. This is the process of recursion. Okay. Now the question is, why we need to call this function again? What's the purpose of calling this function? What you want to repeat me? Shweta, Akash? Yeah, Hassan, I will answer that question. You are asking a great question. I'll answer that. Definitely, I'll answer. Okay. I'm saying that when I was defining this concept, I am calling a function, and in this, I am calling another function. But when I define recursion, recursion says when a function calls itself. It means when I am having a function fun, and this function fun is calling itself only. So this is a procedure of recursion. But now the question is, why a function calls itself? What is the need of that thing, right? We are clear with what is recursion, but why recursion? What is the need of doing this thing? What is the purpose? Okay, so let's start with some story. Okay, let's say there is a classroom, and obviously some students always come late in the class. There are always few students which are latecomers, right? So let's say students come late. Okay, let's say, let me name this Rahul. Okay, someone is Priya. Okay, and what teacher do? Teacher decides that whoever comes late, he will give some punishment to the student. Okay, and what would be the punishment? Let's say it will be, the punishment is like that they have to solve some puzzle, or they have to solve some problem. Okay, so when the first student Rahul comes, so teacher decides to give him some problem that he have to perform the addition of two numbers, sum of two natural numbers, 1 plus 2. Okay, then Priya also comes late, so teacher decides to give her some difficult problem. Rahul is not that late, that much is Priya, so teacher decides to give complex problem to Priya. So he asked to solve her 1 plus 2 plus 3, sum of three natural numbers. Okay. Then suddenly one more student comes late in the class. Let's name this as what to name? Let's name this as Akash. Okay. So when Akash comes, again teacher finds that students are still coming late, so he decides to give some more complex problem. Okay. So he asked to solve sum of first four natural numbers. Okay. Then again one more student comes late. Let me write that as Mira. So whoever comes that much late, teacher will give that much complex problem to the student. So teacher asks her to solve the sum of first five natural numbers. Okay. But Mira is smart enough. Okay. She learns that teacher is giving the complex problem, but if Akash solves the answer and have 5 in that, five in that, right? So what Mira did, she asked the answer from the Akash, and she added plus 5 into that. So what he did, he asked the answer from the Akash, and added 4 in that, right? So get the answer in very less time. So what Akash did, and added plus 4 in that, right? Now Priya asked, right? Now only operation, only so what Mira did, Mira instead of performing the calculation, from Akash. Similarly, problem into simpler one. Try to solve that problem, or this will be very helpful to accomplish your task. Where in all other follow the same concept. So lagging video, your voice buffering. Okay, let me check once what's happening. Is it fine now? Now can you hear me properly? There is no internet. Okay, let me for some time stop. Okay. Is it fine now? Is it fine now? I think this is working fine now. Okay, it will work fine. Yeah, I'll repeat the example. Just a minute. Let's check whether network issue is clear or not. I'll repeat the example. Okay, perfect. Me? Give me one more minute. Okay. Is it fine now? I think everything is fine now, right? Perfect. Okay. If it's clear, tell me in the chat. If it's clear, I'll repeat the example. Give me thumbs up if it's clear to you. Now it's fine. Yeah, it's okay if I'm hidden, but you will get the concept, right? Still perfect. Yeah, fine, fine. Yes, perfect, cool. Okay, let's start again. Someone is still saying lagging. Is it fine now? Okay, so I'll yes, 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 no, yes, 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 yes. Okay, perfect, cool, cool, cool. Okay, so how many of you want to repeat me the example? Do you want me to repeat the example? Repeat. Okay, perfect. Okay, listen, listen, listen. Okay. Yeah, let's start again. Okay, we started with the recursion, and I said that when a function calls itself, what does this mean? Why do we need a function calling itself? What is the reason behind this? Okay, so everyone says that the basic reason is to divide the complex problem into simpler, to break the complex problem into the small simpler, or we can say smaller portions, so that we can solve that problem. Now the question is,
Excuse me,
how,
ma'am.
what does this mean? Why do we need
Ma'am, am
a
I
function
audible?
calling itself? What is the reason? Yeah, you are audible. Okay, so everyone says that the basic reason is to divide the complex problem
Ma'am,
into
your voice is
simpler,
actually
to break the
coming
complex problem
twice.
into the
Actually,
small
there's an
simpler,
echo
or we
from
can
your
say
side.
smaller portions,
Ma'am,
so
could you
that we
just
can
log
solve
out
that
and come
problem.
back again?
Now the question, yeah, we can do that. How? Okay. And can you give me a minute? Can you tell me, is it fine now? Is it
No,
fine now?
ma'am, there's still a background noise
Your
coming. Just,
voice is actually.
ma'am, can you just log out and come back once again? I
Yeah, yeah,
think
yeah, yeah.
students are also facing the same issue. Guys, just wait for just 1 minute. Ma'am is coming back again. Those people who are facing the lagging issues, their problem will be solved. I guess ma'am is having some kind of network issues. So just wait for a while. Until then, guys, whatever doubts you guys are having, just write it in the chat box. Ma'am will be clearing it soon. And anything else regarding the essentials, whatever doubts you're having, just write it in the chat box. Either ma'am or I will be like solving your doubts, or we will be like giving you the solutions in the chat box itself. And those people who were not able to get the link for the telegram link or the assignment link, guys, everything is written in the description. Just go and have a look over there. You will find everything. um, that's it, guys. Kansha ma'am, echo from your side. I don't think echo is coming from my side. If it's there, then Oshin, please do let me know if there's an echo from my side as well. Anything else, guys, just let me know. uh, Indrajit, we are live. Yeah, I'm pretty sure that we are live. Shivam, the data science essential, which essential you're talking about, just let me know. See, the thing is, essentials is free for everyone, but the courses which we are providing, the PGP FS courses, that are paid, and just go to the contact us section from Let's Upgrade and just contact the people, and you will be getting to know all the details regarding our PGP and FS courses related to data science. Apart from that, the DSA courses which we are providing in YouTube Essentials, that is free.
Yeah, please
uh,
allow me.
yes.
Is it clear
Yes,
now?
ma'am. Now it's yes, ma'am. It's audible and it's perfectly fine.
Okay, please, please.
Yes, ma'am. Thank you. We can continue.
Yeah. Now, am I clearly audible to everyone? Students, am I clearly audible? If you'll tell me, I'll get to know if you're with me. Yes, ma'am. Okay. Yes, ma'am. Okay, let's start. Okay. I think there will be no issue further. Okay. We will continue. I'll repeat the process. Okay. We'll listen. Recursion is somehow, some students say that they find that topic very difficult. Okay. So I am telling you with the example so that you grab this concept easily. Okay. So listen carefully what I am telling you. And if you still find any difficulty, I'll tell you that how to solve that problem. Recursion is all about when a function calls itself. Okay. When we say that what is the requirement when a function calls itself, why do we need that thing? So the answer is very simple, that to divide a complex problem and break down into simpler or smaller problems. Okay. So firstly, let's start with an example. So I took an example of a classroom. Okay. So there are students. So when us in a classroom, there are obviously many students which come late. There are always latecomers in the class. So I took an example when students come late in the class. I took example as say Rahul. Can you see my screen? Can you tell me in the chat once that are you able to see my screen? Okay, someone is saying perfectly audible. Can you tell me? Can you see my screen? Please tell me in the chat whether can you see my screen? Yes, no. Yes. Oh, yeah. Oops, absolutely. Okay. It's visible. Okay. Where I am taking example, let's say Rahul, Priya comes late in the class. So teacher decides to give them punishment. Okay. So what kind of punishment? So teacher asked Rahul to solve a puzzle, solve a question. Okay. So what teacher did? He asked to solve a puzzle. You have to calculate sum of first two natural numbers. Okay. Okay, perfectly fine. Then Priya also comes late. So teacher gives her a very more complex problem than Rahul. He asked to solve her sum of three natural numbers, first three natural numbers. Then suddenly one more student comes late in the class. Okay, let me name this as Akash. Okay, when Akash comes late, teacher decides to give him more complex problem. He asked Akash to solve the sum of first four natural numbers. Okay. Then listen very carefully. This is all about recursion only. Okay. So let's take one more student. Mira also comes late in the class. Okay. So what teacher did? He gave her more complex problem. He asked her to solve the sum of first five natural numbers. Okay. Now when teacher asked Mira to solve sum of first five natural numbers, Mira is not a hardworking person. She is quite smart. She decides that she will get the answer from the Akash because teacher asked to calculate him sum of first four natural numbers. Okay. What Mira will do? She will get the answer from the Akash and add 5 into that so that she can get the answer. So she acted smart, right? What she did, instead of calculating
this much number, instead of performing this much of addition, what she did, she get this answer from the Akash and performed the addition of 5 only. Okay, then what Akash did, Akash learned the concept of Mira and he applied it to the Priya. What he did, he asked the answer from the Priya that tell me your answer, so that he can perform the addition 4 with that value so that he can get the answer. And again Priya did the same thing. Priya asked Rahul to tell me your answer so that I can perform plus 3 into that. What happens here that everyone behaves smartly, that instead of calculating every single value, instead of performing so many additions, they perform addition over here only, right? So what Mira did, she, instead of solving this much complex problem, she divided this problem by saying that someone please provide me the answer, I'll add 5 into that. Who is that someone? Someone that is Akash. That give me your answer, I'll add 5 this into it. Okay, so in this way recursion works. What we do, if someone asks you to calculate or to add sum of first 5 natural numbers, how can we do that? If someone can give you addition sum of first 4 natural numbers, we simply have to do the addition with 5 only. Now what's the next thing? If someone gives you this much addition, what you can say, please someone give me the addition of this value, I can perform this much addition. Then you can ask that I, please give me this much value, I can add this thing, right? This is what Mira is doing, this is what Akash is doing, this is what Priya is doing. There is no one to help Rahul, so Rahul has to calculate its value by own, right? In this way, what is happening that Rahul is working hard and everyone else is taking benefit from it, right? So what we did, whenever we have to perform sum of first 5 natural numbers, what we can do, we can divide our problem into smaller problems so that we can achieve our task easily. Now let's implement this procedure in our programming term, in our algorithm terms. Okay, tell me how many of you are clear with this example now? Are you clear with this example? Tell me in the chat. Yeah, tell me in the chat. Yeah, someone is saying yes. Okay, perfect. Okay. Now, let me take an example. Clear, clear. Yes, ma'am. Yes, ma'am. Okay, now. I think it's there is still some lag. I can get your reply very lately. Yeah, perfect. Now, let's implement this procedure of recursion in our algorithm. What's our algorithm? Firstly, listen very carefully, again very carefully. I want to perform the addition. Let me take that as sum. Okay, I have to perform the addition. What I'll do, I'll take the first 5 natural numbers, the same scenario of our example, right? So what I can do, I'll say that let me write this as n, function calling. Okay, so when I define this function, let me define this function. When I say that I want to perform the sum of, let's say, n is equals to 5 right now. Okay, what can I do? I can simply say that n plus n is 5. 5 plus, please provide me the solution of this much. So can I write that, please calculate, again perform sum with n minus 1 terms. Okay, what does this mean? That now 5 plus, I have to solve this question for sum 4, right? This is what we did, that this is the problem now. Now again what we will do, we will divide this problem into smaller problem. What's that? That please someone help me, and what to do, give me the answer for this. I can perform the addition of 4. So when I call this function sum4, what will happen? Again I'll use this function 4 plus sum of n minus 1. What's n minus 1? 3. Perfect. Now When I have to perform the addition for 3 numbers, what I'll use? Again, someone provide me this value, I can perform this addition. Again, what I'll do? Same, when I call this function, n plus sum n minus 1. What's that? 2 only. Is it clear? Tell me in the chat quickly. Are you with me? Yeah, we will define that, Darshan. Wait. Let's first understand this concept only, okay? Now, listen. I'm saying that in my main function, I have asked someone to call this function sum for 5, okay? And I'll give me the result. I'll store that result into, let's say, R, okay? Now, when I define this function, what I'll do, I'll define this as int sum, and if I'm passing some argument, integer value, so I'll define that data type and some variable name. So I'm using that as n. So now n is considered as 5 here. Now listen carefully. What I did, I said that divide this complex problem into simpler problem. So I did this thing, that simply return this thing. Perfect. Now, what I want is in recursion, again listen carefully, recursion says that divide the complex problem into smaller problems, right? But if I don't define any base condition, what will happen here? 5, then it call for n minus 1. It means 4, then it will call for n minus 1, 3. Then 2, 1. After that 0, minus values and so on. It means it will go into infinite loop and our memory is limited. So to avoid such conditions, we have to define some limit. Like in this situation, we said that Rahul is the first one to solve this problem, right? After that, everyone is taking benefit from that, right? Similarly, we will define here as the base condition, that this is the base condition. This must be solved. Other than this, you can directly take the value. It means here Rahul has to solve the problem. Priya, Akash, Mira can take benefit from Rahul directly. So Rahul is defining here as the base condition, right? So in general, we define base condition as, if I write here that if this value n, if I want to perform the addition, sum of first one natural number. One natural number means it's one itself. We don't have to perform any addition. So we can take this as base condition, that if n equals to 1, it means there is no need to perform any addition. We can directly return 1 as the result. Other than this, we have to perform the calculation. We have to calculate that. If someone says that I want to perform the calculation for n equals to 2, what will happen? See carefully. When n is 2, first it will check if n equals to 1, condition is false. So what will happen? It will move to this part. What it will do? 2 plus, please provide me answer for this. So we will execute this sum. What will happen? Now n is 1. So if n equals to 1, what we will do? This condition is true, so it will return 1. It means it will return 1 and we can get the result. Tell me, how many of you are with me? Did you get this concept? Waiting for you in the chat. Yeah, tell me, how many of you get this concept? Yeah, someone, okay, clear, okay. Perfect. Yes, ma'am. Yeah, we will talk about the disadvantage as well. Firstly, learn this concept. The very first point is that whenever you learn any topic, you must understand this thing, that what is the need of coming this topic? Why this topic comes into the market? There must be use of that topic. So first, the usage of that topic. When you use that topic, then only you will understand the drawbacks of that topic, that there is some issue in this topic. We should implement new topic, or we should develop new topic, that there are some these problems, these are limitations in this particular topic. So firstly learn the usage of a particular topic, then only discuss about the drawbacks. Okay, then only you will understand that these are the drawbacks in these topics. So right now I'm telling you about the particular usage of the recursion, that in what scenarios we use recursion. If I talk about the tree traversal, when you implement the trees are implemented using recursion only. Recursion plays very important role in tree traversal, implementing binary search tree, AVL tree, in all these concepts. So recursion is very, very important. Okay. Okay, perfect. Yeah, I'll execute. Definitely, I'll execute. Okay. So what I did basically, when you write a recursion, how to write a recursive functions or how to write a recursion, we will simply say, consider 2 points. If you can divide your complex problems into smaller problems, then definitely you should go with the recursion. And you must take care of defining the base condition. If you don't define the base condition, it means it will run infinite, or it will exhaust your memory. It means it will give you segmentation fault. It will say that memory is full and you can't enter more values. So you always have to define the base condition whenever you write a program. Okay, so for time being, let's implement this. Let me show you the implementation. We are in our editor dev C++, so let's write that thing. Okay, in main function, what we want in our main function, let's take some value. That for that value we want to, let me take 5. Okay, you want to take value from the user as well, so let's take from the user only. Okay, scene. Firstly, let me tell the user that please enter the value. Okay, after that I'll ask to input in the n only. Okay, now what I want to store the result when I call my function sum. Let me call this with value n only. Perfect. Now when my result was stored, value gets calculated and stored in the result, I want to display that value, so I defined this thing. Now when I called a function sum, definitely I have to define that function. So let me define that function. Some function is returning something, integer value, so we must have to define return type as integer. Here we will write int here. After that, let me write the name, and there is one argument which is passed here, so I have to write one argument as well. Now what's the condition? I want to solve the perform the calculation. I want to perform the addition of first n natural numbers. For that, I'll define the base condition, that if n equals to 1, it means there is no need to perform the addition. This is the single value only, so simply return 1. Right, other than this we have to perform the calculation. What calculation we want? We want simply to calculate. I will perform the addition n. I can add n value to what? If you give me the result of n minus 1, which Mira did, that I can add 5 to my value, but give me answer of sum of first 4 natural numbers. So I write this statement only. Yeah, Prasad is saying in recursion base condition is important. Yeah, it is very important to write the base condition, because if you don't write the base condition, your loop, your recursion, your function calling will go into the infinite calling. So how will you stop that? So base condition is used to stop the infinite calling. Is it clear? Are you with me? Now, when I define this thing, this is all about my program. What I'll do, I'll execute this. When I execute this program, enter the value, let's say 5. So I'm getting the answer. 15 as the answer. Let's try for a smaller value. Let's try for 3 only. We are getting the answer again, right? Yeah, you will get the assignment link. You will get that Google form, right? Firstly, focus in the on this program only, that when I use this function, we are getting the result. What we are doing? We are dividing our complex problem into smaller problem. And can you see, I am calling this function sum again and again. But before, firstly, I called this for 5. Then I called this function for 4. And in this way, I divided my complex problem into smaller problem. Are you with me? Okay, perfect, cool. So how many of you understand this concept? Did you understand this recursion concept? Okay, let me draw again, let me take same example. We are using sum with 5. I want to perform the addition of first 5 natural numbers. So I code this thing. So every time what I was doing, I was calculating this thing, right? N minus 1. What n minus 1 is? Sum for 4 values. So what I did, I performed 5 plus sum of 4. Again, I'll call this function. What will happen this time? 4 plus sum of 3. Listen very carefully, okay? Now, again, what I'll do, I'll call this function again. This time it will perform 3 plus sum of 2. Right? Again, because every time what I am doing this thing. My function is calling for one lesser value. That's why with 5, then 4, then 3, then 2. Now when I call this function, it will call for one lesser value. What's that? 1. Right? But when I call for this 1, we have defined this as the base condition, that when n equals to 1, simply return the value. Instead of calling the function, I am returning the value this time, right? So this time value gets computed. It will calculate this value and give the result to this value. Then 3 plus 3 is calculated and gives the result to this particular function. In this way, our recursion works, and we call this as recursive tree. This is a kind of tree we in general draw while calculating the recursion. Or if I talk about the memory, stack memory, then how will you do that? Firstly, obviously your main function starts executing, and in that function you call this sum n. So your execution starts here. Then you called for 5. 5 will stop executing because you have to calculate the result for one lesser value. Because Meera said that I can't calculate until Akash gives me the answer. Although Meera can start performing her task, but she was waiting to get the answer from the Akash only. So what she did? She said that please provide me answer for this sum of 4. So Meera stops executing. And now what Akash did? Akash also stopped his execution because he wants the answer from Priya. Again, what will happen? This Priya will calculate, but Priya again also stops her execution. Why so? Because he wants the answer from Rahul, right? So before that, sum 2 will get executed. Now, when I have to perform sum 2, again I will do this thing. It means again I have to call a function. This time, what will happen when I called someone? What happened? We got the answer that instead of function calling, we are having a value this time. So this function returns 1 and it will provide this to sum 2. Now sum 2 performs it operation that I have to perform 2 plus the value which I get. It means what Priya will do, the Rahul gives answer to 2 plus 1, 3. So Priya will perform this addition only. And with this value, it gets to this, and the same process repeats, and finally in our main function we get the value in our result which we are printing. This is our stack activation record. We also call this as activation record. This is the main concept of recursion. So tell me, how many of you get this concept? Recursion is very important topic, so please understand this concept thoroughly. Okay, once you get this concept, you can solve any complex problem. When we come up to the tree and graphs, trees uses the concept of recursion. Or when we talk about the sorting techniques, quick sort, merge sort, they also use the concept of recursion. So if you understand the basic foundation of recursion, that how to write a recursive function, how recursive calls are there, how stack works while we are using recursion. So if you are clear with all these concepts, then you can easily solve complex problems while performing sorting, or if you are doing binary search, if you are solving Tower of Hanoi problem. In all these scenarios, you use the concept of recursion. Okay, so when a function calls itself and how to solve that thing, if you understand this concept, then you can solve any problem, you can solve any program. Okay, so are you clear? Are you with me? If you are clear, then in the chat give me some hearts so that I can be aware that you are learning this concept. Okay, yes, you got it. Yes ma'am, yes ma'am, crystal clear ma'am, thank you Indrajit. Yeah. Now I'll explain once. Okay, Mahmood is saying, can you explain once, ma'am? Yeah, I'll take another example. Okay, now with that example, again we will follow the same procedure. Now, see, I am doing factorial now. Okay, if I ask you about 1 factorial, what's that? 1. Oh, some lots of hearts are there. Thank you. Yeah, listen, I'm explaining again. Listen this concept now. I am taking factorial. Okay. If I ask you to calculate the 5 factorial, instead of let me remove this. If I ask you to calculate the 5 factorial, what would be that? Oh, so many hearts. Oh, so many. Thank you. Okay, now let's focus on this next topic. Come to this topic of factorial. If I ask you about this 5 factorial, what would be the answer? How to calculate? We will perform 5 into 4 into 3 into 2 into 1. Right? Now, let's see. Again, let's take the same example that we are having Rahul, Priya, Akash, Meera, and let's take one more guy. We will take that, okay? Rahul have to perform the operation for 2 factorial. Then Priya has to perform for 3 factorial, 4 factorial, and 5 factorial. Again, see what Rahul has to do. Rahul has to calculate 1 into 2, right? What Priya has to do? 3 into 2 into 1. What Akash has to do? 4 into 3 into 2 into 1. And what Meera has to do? 5 into 4 into 3 into 2 into 1. In earlier example, we simply have to perform the addition. This time we have to perform the multiplication. Again, what Meera will do? Again, Meera will behave smartly and she will ask the result from the Akash. What result? That please provide me the multiplication of these values so that I will simply multiply that value with 5. Akash says, this is nice. I will follow the same concept again. So please provide me answer for this. And I will simply multiply that value with 4. This is perfectly fine. Priya also follows the same concept. What she will do? She will ask from Rahul and multiply 3 only. Right? Now, Rahul has to perform. Rahul has to calculate the value. What we can see that to calculate any particular value, we are dividing that problem into smaller parts, that instead of calculating for 5 factorial, firstly calculate for 4 factorial, then for 3 factorial, 2 factorial. In this way, we can get our result easily. Perfectly fine with me? Okay, now let's move to the coding part for this. Again, what we will do in our main function, what we will do, we will simply call for the factorial. Let me define that as fact. And I'll call for 5, again 5. And I want to store that result. Let me store that result into some R. If I'm going to call this function, let's focus on this function only. What to do? I'll write this function and let me write this 5 as n here. Right? Now, firstly, let's write that in terms of breaking the problem into smaller problems. What we want? We want n into Please provide me the answer. It means I want give me the answer for 4 factorial, right? So what can I write here? Fact n minus 1. Ame, very nice. You are doing the perfect. Preksha is saying that n into fact n minus 1. Mehakdeep is also saying the same thing. Very nice. You are getting the concept. Perfectly cool. Okay. What should I write the base condition? That for 2 factorial, I have to perform the calculation. For 1 factorial, I don't have to do anything. I simply have to write 1. So, can I say if n equals to 1, simply return the 1. Otherwise, perform the operation. Else, do this thing. How many of you are with me? Yeah. N into Gauravpal, n into fact n minus 1. Right. So let's do the implementation. Firstly, if I ask you to design the recursive tree for this, how will you design? If I say that I called the function for fact 5, now design the recursive tree for this. So what would be that? 5. If condition is false, so we move to the else part. What would be that? Perform 5 into again call the function. What's the function? N minus 1. Again, it means call for the fact 4. Right? Now, again, what would be that? 4 into fact of 3. And then if I call for this, 3 into factorial of 2. Again, I called for this. So, what I'll say? Factorial 1. And with this factorial 1, what I'll do? I simply say that when value is 1, simply return 1. It means 1. Once this value is calculated, we give this result to this fact 2. And then 3 into 2 is calculated 6. Here 2 is returned. Here 6 value is returned. 6 4s are 24 is returned to factorial 4. And then what will happen? 24 into 5 is calculated and 120 is returned to this. And this value is stored in our result which we get as the output. Yeah. Yes. So I think everyone is with me. Let's implement this, okay? So that you get this concept easily. In our previous example, previous scenario, we calculated the sum of first n natural numbers. Here we are performing the factorial, okay? Yeah, someone is saying please once send the attendance form. You will get that in the description only. Over there you can check. And Let's Upgrade team is also providing you that in the chat as well. So over there you can also see. Okay, let's implement this. Now again, I'm here. Let me completely erase this. Okay, I'll not erase this portion. Let me erase this thing only. Okay, what I'll do, I'll take some value from the user. And what I'll do, I'll call some function fact with n. And I want to store that result in this. So simply result. Okay. Now the main point is to define this fact. So definitely it is returning some integer value. So I'm writing that thing. Then function name. And there is one argument. So I'll write that into the arguments. Now what's the situation? We have to define the base condition. What would be that? If n equals to 1, simply return 1 because 1 factorial is 1. There is nothing to calculate. Else what to do? Return n into. Now here we are using into multiplication. Fact with n minus 1. With this we can easily get our result. So tell me, how many of you understand this concept? How many iterations is there? What iterations you are asking? Let me take 4. So we are getting 24 as the result. If I again execute, let's take 5. I'll get 120 as the answer. Again, show me some hearts in the chat if you are getting this concept. here we don't consider the iterations actually, Akhilesh. We talk about the function calling, that how many times our function is being called. This, if you are talking about the time complexity, this is the scenario. Okay, that when you talk about the time complexity, we talk about the how many times or how many times a particular function is being called. Here we are calling function again and again. It means how many times we called this function and how much time this particular function takes. In this way we calculate. Here we are discussing about the basic scenarios. If you further go into this DSA course, over there you will learn about the everything, that how to calculate the time complexity, how much space this recursion takes. Obviously, if we are, what we are doing, let me show you over here, that in this point, what I did when I was using this tag, what was happening, that this when we have to perform for some 5, I am storing this, I am storing this, so many functions, so many values are stored in our memory. It means it takes lots of memory. And what was the concept of DSA? That we have to implement any particular program in such a way that it takes less time and less space. So if recursion takes so much of memory, why we are using this concept? What is the necessity of using this concept? So these are the very deep points to discuss. Firstly, on today's session we are discussing about the basics, that how to write a recursive functions. If you really want to learn these further topics, please enroll yourself. Go to the website, enroll for full stack courses. Over there you will get full stack web development course, data science course, and you will grab these concepts as well. Okay, data structure. In these 2 days we discussed about the logics, that how to build your logic, and today we are discussing about the recursion only. But in general, data structure is considering so many topics, right? Like arrays, linked list, stack, queue, trees, graphs, dynamic programming, greedy approach. There are so much to learn, right? So this is a complete course. DSA is of complete course of all these topics. In these 2 days, I am just telling you that how you can learn recursion and how can you build your logics. Okay? Yeah. Now, moving ahead, this time you have to tell me. You have to, everyone, I think everyone knows about the Fibonacci series, right? How many of you knows the Fibonacci series? Okay. Please tell me in the chat, how many of you know about this concept? What's this concept? Yes, ma'am, I know. Then tell me in the chat, what's that series? How to write that series? Tell me, I'll write that. Okay, Aman is saying no. Oh, no issues, I'll explain that. But firstly, tell me, what's this? What is this series? Let me tell you. This series is what we in general do. There are two values. We write the next value by adding these two values. 0 plus 1, then 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. Right? This is the Fibonacci series. Now I have to implement this. This is your problem, that when someone asks you to implement this, that this particular series, how can you think of this? What would be your logic? N minus 1 into n minus 2. Someone is saying, I guess. Okay. N minus 1 in, what you said? N to n minus 2. I'm saying that I am performing the addition here. I'll take two previous values and I perform addition on that so that I can get the next value, right? So instead of saying this, I can say I am adding values, right? What are you asking, Shriyang? What about all topics of DSA? Sum of last two numbers is our next number. Perfectly nice. Yeah, you are saying, Ravinder is saying n equals to n minus 1 plus n minus 2. Yeah. So what we are doing, we are calling the same function and again. So we can use recursion here, right? So how to use recursion this time? Tell me what to write. I'll write that thing only. In the chat, please mention. I'll write, follow the same way. We have to follow. Okay, perfectly fine. Rishabh said return fib n minus 1 plus fib n minus 2. Very nice. Simply, let's define our function. Let me call this as fib. Obviously, we will pass some integer value so that we can get result up to that particular value. What in the result we want? We want the addition. Okay. So how can we get that? Okay. Firstly, what we want to return, everyone is saying fib n minus 1 plus fib n minus 2. This is what is happening again and again. Right. Okay. So what we were doing, let's take this. If I want to calculate for fib 3, what I'll do, I'll say that call for 2 and for 1. Right. What's for 2? Call for fib 1 and fib 0. Right. If I call this further, listen very carefully, okay? I want to perform the addition for fib 0 and fib minus 1 this time. Why to go to negative? We can define this as our base condition, and with 2, if I'm getting this, I can define this as my base condition, right? So if I say that n equals to 0, then simply return 0. Or if n equals to 1, then return 1. Other than this, we can perform the recursive calls. So what will happen for fib2? If I call this function only, what will happen? It will call fib1 and fib0. So 1 plus 0, we will get 1. This is what we are getting. 0, 1 and this 1. If I consider this as well, I want to perform operation over here. What we will do? We will consider fib3. It means it will perform this whole operation. How many of you are getting this recursive tree? Tell me in the chat. This is not assignment problem. We are solving it. After this, I'll give you some assignment problem, okay? In which memory this variable n will be stored and function fib will be stored. Ganesh, if to explain this topic, it needs some time to explain you the concept of memory. In general, when we talk about the memory, we consider the 4 segments. Okay, static memory, dynamic memory, text segments, all these stuffs. Okay, so for you have to wait to get the answer for this question. Got it, got it. Yes, ma'am. Understanding. Perfectly fine. Pankaj Mahakdeep is saying clear. Very nice. Okay, at the end of this session, I'll give you some assignments. To complete that assignment, you first have to join the Telegram group. Okay, over there you will get the assignment link. Okay, yeah, nice. Okay, clear. Okay, now this is about the recursive tree. Now, if I want to calculate the answer, what would be the answer for this? Firstly, I have to solve this fib2, and after this result, we will get the answer, right? So let's implement this. Okay, let's move to the implementation part. Okay, now tell me. Let me firstly erase this portion so that we can write from the very beginning. And let me erase this portion as well. Okay, we will take some value from the user. After that, what we will do? Let me write some function fib, which will return some value. Let me write this as r this time. Okay, fib, and I'll call with n, whatever user gives me the input. Let me define now the function. I'll write this int fib. There is some argument, so I'll write that as well. So what we are saying that for 0 and 1, we don't have to do anything. So if n equals to 0 or n equals to 1. Now tell me, what to return this time? Yeah, tell me what to return in this time. Yeah, Yeah, someone is saying execute it, ma'am. Yeah, I'm executing it. Check. Okay. If 0, then return 0. If 1, then return 1. Let me show you here. If we are taking 0, then 0, 1, then 1. What to write here? We can write n here so that whatever value, whether it is 1 or 2, we can return immediately. Right? Other than this, in else part, what to write? Return for n minus 1 and plus fib n minus 2. This is the basic operation we have to do. Yeah, 0 1 0 1. Everyone is saying correctly fine. 1. Okay. Now perfect. Nice, nice. If I execute, I want to print, get the result. See out. What I'll say R. Okay. Now what will happen? Let's execute this. Let me take, enter the value 2. So we are getting 1 as the result, which we discussed on the whiteboard here. That if I'm taking this 2, what we are getting? 1. Okay, let's try for some other value. 3. This is giving me 2, right? So in this way, you can calculate perform the operation and you will get the results. Okay, now this time I am providing you assignment. You have to tell me what to tell me. Listen, this time you have to tell me that I'm giving you function fun and I'm giving you n here. Okay, if n equals to 0, it means I'm giving you some base condition. Okay, else you have to do, you have to tell me the tree for this. Okay, design tree for this. Return fun n minus 1. Now tell me, how will you design tree for this? Any idea, any hint? This time, can you see I have given something else? Every time we were taking a single statement. What we were taking? We were in else part using only one statement. Simply return this thing. This time we are doing something else. What we are doing? We are using two statements. Right? It means it will give me the result and it will call the function both thing. It means I'll get the result somewhat different, right? Can you tell me how we will get that? Okay. If I provide you solution for this, I'll give you some other assignment. Let me give you some idea. Let's take n equals to 3 this time, right? If my n value is 3, what will happen? I am calling my function fun for 3, right? If condition is false, so we move to the else part. What will happen in the else part? Listen very carefully, okay? When I move to this fun 3, what is happening? The very first statement is print the value of n. It means print the value 3. So in my result screen, output screen 3 should be shown. After that, I am calling this function. What function I am calling? I am calling fun2, right? So this function is paused at this point and this function starts executing. Again, listen very carefully. When I called for fun2, what is happening now? Fun2. Again, we move to the else part. Again, it is saying print the value. What to print? 2. And again, we are returning fun n minus 1. It means again we are calling fun1. 3, then 2. This time I am calling fun1. What I'll do? Now I'm writing at the bottom here. When I call this function fun1, what will happen now? Again, value will be printed. What's the value? N value. 1 will be printed with again function calling. What function calling? 0. So in this way we get the result. Now this time I will call fun 0. This time if condition is true, so we are returning from here. So if someone asks you that if I give you this program, what would be the result? The result would be 3, 2, 1. In this way you get your result. Because firstly when this statement works, this time fun3 is waiting to get fun2 completed. When I call fun2, this time fun2 is again paused so that fun1 gets completed. Again at this point, now this returns the value and everything is returning. And finally we are getting this as the result. So tell me, how many of you get this concept? We will not get 0. Why 0? We are returning here. We are not printing that thing, right? So 3, 2, 1 would be the answer. Why we are using 2 n values? Where we are using 2 n values? Can you tell me? If you want to print the 0 as the result, you have to mention cout 0 as well here. Cout n. That would be different scenarios. Okay. 0 is not included in your answer because if you call, listen, when you call fun 0, what will happen? This statement will get executed because if condition is true this time, at this you are simply writing return. You are not printing anything. But in else part you are writing that print value first. That's why here value is printing and here 0 is not getting into the result. Okay, yes ma'am. So yeah. Hmm. When cout is not written also. So in that case, you will write something else. Like in this scenario, when we were returning, listen, let me show you this example. This time, when we were performing addition, what we were doing? We were returning this only and we are storing that value in the result itself and we are printing result. So every time we take different scenarios. I'm just taking an example to explain you that how recursion works. If someone gives you multiple statements, then how you will execute that thing? Yeah, perfect. Okay. Okay. Now let me give you some assignment this time. Okay. Let me write some code for that. I'm giving you 2 assignments. Okay. You have to do those assignments. Okay. Instead of like take this, let me take void this time. Okay. We are taking something different this time. Okay. If 0, then simply return. Otherwise, now listen very carefully. This time you have to perform this operation and after this you will perform this operation. Okay. This will obviously take some time to get understand. Okay. So listen, this time I am taking if n equals to 0, you have to return. But in earlier question, what we were doing, we were writing cout here, then I am calling the function. But in this assignment, what I am giving you that there is function calling at the first statement and at the second statement, we are printing the value. Now you have to tell me the answer for this, that what would be the answer or result for this particular program. Okay. Yeah. Okay, perfectly fine. Okay. Now tell me. Okay, let me give you some other question as well. Let me revise you firstly. We started with recursion. What we did, we discussed about recursion that when a function calls itself, right? Then after that, we learned about function calling, that what does function calling mean. So we took an example with that in main we are calling fun, and in fun we are calling another function fun too. But the question here is when a function calls itself, repetition. So here we use the concept of recursion. But what is the need of this? To divide or to break a complex problem into smaller problems, right? So for that we took example sum of first n natural numbers, then we took example of factorial and then Fibonacci series. All these are examples of recursion. Okay, these are the very basic examples. Okay, if you want to learn recursion thoroughly, you can try with binary search. We can implement binary search using recursion. You can go with quick sort, you can try merge sort. All these algorithms uses the concept of recursion. Other than this, there is a very nice problem, Tower of Hanoi. If you feel you have understood this concept clearly, try this problem. Okay, and we can use recursion in trees as well. Trees, traversal, and all these things are being implemented using recursion only. Okay, so every topic has its importance in DSA. Although recursion increases the space, so still why we use this, or how we can calculate the time complexity for this recursion, we will, when you enroll for the course, you will learn about these things over there only. Here I have started with the very basic portion, that how you can do the recursion. So are you with me? Void function. Void means you are not returning anything. This is a part of programming language. Okay, if whenever you define any function, before that you write return type. It can be int, it can be float, any data type, or it can be void. Void means you are not returning anything. Okay, if you are getting confused with this part, I am returning here, it simply means that if this is true, I am not returning any value. Just get out of this particular function. Okay, it will return, it will stop executing this fun. This fun is completed and move to the main part if my fun function is being called in the main only. This means this only. Yeah, if you want to learn Tower of Hanoi, it takes lot of time to explain that. Right now I'll not explain. In DSA course you will definitely get this point of Tower of Hanoi. Yes, 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 yes. Okay, so yeah, void means not return any value. Perfect, you are right. So I'm not mentioning anything here. It is simply returning from the function only. If I write something, it means it will give me error if I mention return to one and I'm writing void. It means this is something wrong. Okay. Simply I can write this. Return nothing. Yes. Okay. This is the first assignment you have to do. Let me tell you one more assignment which you have to do. Okay. Let me write that. And this assignment which I'm giving you right now, firstly try by yourself. Okay. Then if you want to check or learn about this concept thoroughly, this is gate question. Okay. In gate as well, there are many questions from the recursion. Recursion is a really very important topic. So in gate exams, you will find 1 to 2 questions from the recursion only. So try this question. You can call this function for, let's say, I'll give you 4. Try with 4. And you have to design the recursive tree for this. Okay. Could you please explain tree traversal? Right now we are discussing recursion only, but I will not explain tree traversal. But you will, when you join the course, you will get everything over there. You will learn about every single topic, whether it's array, it's linked list, singly, doubly linked list, queue, circular queue, double-ended queue, trees, graphs, dynamic programming, greedy approach, every recursion. You will learn every topic in detail. Okay. You didn't get what you have to submit. You have to tell me the answer for this, that how this particular program gives you the result, because there is cout statement. It means it will give some result on the console. So you have to tell me that answer in this first program. And in this second program, you have to design the recursive tree. When I am calling for get 4, how will your tree look like? And the tree which we are discussing, like this one, and like in Fibonacci we did this tree. In this way you have to design the tree for get 4. And what would be the answer? Here again we are using cout n. You have to tell me that thing only. Yep. Yeah, cool, perfectly fine. Okay. Again, at the end of the session, I am again telling you data structure and algorithm is the core subject. So I insist you to practice very hard on the data structure and algorithm so that you will learn, you grab the concepts in a better way. Okay. Yeah, handwritten will be fine. Yeah, Shweta, you can give the handwritten. Yeah, heap will also be covered. When we talk about dynamic memory allocation, over there heap topic will be covered. So every topic of data structure and algorithm will be covered. Okay. So practice data structure and algorithm. And if you enroll for any course, if you go for data science, web development, Android development, data structure and algorithm is very core. So try to improve your logics. Firstly, write your logic on paper and pen, and then implement that, then execute that program. Firstly, try manually, do the dry run. After that, when you implement, you will get the more clarity of the topic. Okay. And let me remind you once again, for the certificate, you have to register yourself on the website, you have to mark your attendance, and you have to submit your assignments. Then only you will get the certificate. Okay. And the assignment link, you will get that assignment link on the Telegram group, and you can join the Telegram group, and the link is provided in the description. Okay. Now let me tell you how you can enroll yourself for the full stack courses. Go to the website letsupgrade.in. Over there you will find the programs. Okay. Full stack web development program, full stack data science program. You can directly click on enroll now, and you can enroll for the particular course whichever you want to enroll. Okay. So now tell me in the chat, did you enjoy this session? Yeah, you have to tell me the output only as the assignment in the first program, and in the second program you have to design the tree and tell the result as well. Both. No, there is no exam for DSA. So now tell me in the chat, did you enjoy this session? Yes. Gaurav is saying yes. So did you understand the concept of recursion, that how you solve the complex problem into smaller, or you can always, you have to remind that example only, that how to solve that complex program or how to behave smartly, so that you have to calculate or perform the operations minimal. Yeah. Deadline for the assignment, submit it today or tomorrow morning, till tomorrow morning. Yeah. Yes. Okay. Then show me some hearts so that we can end the session. Okay. Yeah. Yes, perfectly fine. So do yourself, if you understand this concept, I'll insist you to implement tar of Hanoi. Tar of Hanoi is very wonderful problem to learn the recursion. Okay. Okay. Perfect. Okay. Thank you. Let me stop sharing my screen. This is all about our today's session.